Okay, welcome everyone. I'm David Goujon, and I'm together with Monjour that should be here also. I'm the project coordinator of this wonderful project named Response. So just in a 1-minute introduction, this project aims to create 2 positive energy districts. So positive energy district is a urban area where on a yearly basis, this area will produce more energy than actually consumes. So to create 2 positive energy districts in the city of Dijon, which is in France, and Turku, which is in Finland. And we have in this project as well 6 fellow cities who are engaged to replicate the solution that we are testing in Dijon and Turku. And we have one, I think, of these fellow cities together with us today, and it will present his activities a bit later. So I think instead of talking too much, we have a nice video to play today, a video that will introduce the entire project. Carolina, can you play the video, please?
According to the United Nations, the world population is estimated to reach 9.8 billion people by 2050, an increase of more than 25% compared to 2021. This population growth is mostly in urban areas, bringing difficulties to the production of safe, clean energy for such high demand. This has harmful consequences for the climate and ultimately for our own well-being. Air pollution is now one of the biggest environmental threats to human life. That is why the PEB and PED concept was born. A positive energy block, PEB, is a group of at least 3 connected neighbouring buildings, which over a year produces more energy than it consumes. The space composed of those buildings is called PED, Positive Energy District, an energy-efficient and energy-flexible urban area which produces net zero greenhouse gas emissions. We need urgent responses and actions towards a single solution to improve the quality of life for our populations in the decades to come. Air Quality Index helps us to monitor the overall quality of air in a specific area. As we decrease carbon dioxide emission levels, air quality will increase, benefiting people's lives. Following EU's decarbonisation programme, Response aims to introduce solutions to help cities reach climate neutrality by 2050. But is this doable? Stay with us and learn more about Response's purpose and objectives. Response aims to establish a strategic vision for smart cities' energy transition in a way that can be affordable, secure and sustainable. Response solutions are comprised of 5 pillars. The first pillar involves the demonstration of energy-efficient building systems and smart-ready buildings. So, for example, the energy consumption for cooling and heating houses will be lower. The second pillar involves the decarbonisation and smartification of heating, cooling networks. The third pillar deals with heat storage, providing flexibility to the electricity systems. The fourth pillar is to use information and communication technologies to manage energy, e-mobility and e-governance. The fifth pillar tries to engage with the population to actively participate in moving towards resilient and safe cities, enhance citizen participation and raising awareness, and also improve the resilience of cities, social justice and security. Dijon in France and Turku in Finland are the lighthouse cities for this pilot project that will have a duration of 5 years. In both cities, the project will demonstrate various solutions. The solutions to be implemented in the lighthouse cities, Turku and Dijon, will be replicated in the project's fellow cities, Brussels, Zaragoza, Botoșani, Ptolemaida, Gabrova and Severodonetsk. In 5 years, Response expects positive impacts in the lighthouse cities as a result of decarbonisation. It's expected that the greenhouse gas emissions will be reduced by 40% by 2030 in comparison with the year 2020 and 85% by 2050. The increased use of renewable energies, waste heat recovery and storage solutions, including batteries, and their integration into the energy system improve energy efficiency and air quality. Also, the lighthouse cities will act as mentors to fellow cities who will replicate the same measures. The importance of implementing and testing these measures will define how we approach the changes that must be made, so in the coming decades we can finally have climate-neutral cities for all. Let's make a better future for everyone with Response. Response. integrated solutions for positive energy and resilient cities.
So we have the agenda of the day is first we have Jari and I see his camera on that will give an introduction. Then we will have a presentation from Turku side. So Turku is one of the two lighthouse cities. Then an introduction from Dijon side, and then an introduction from two of the fellow cities, which are Zaragoza and Gabrovo. So, Jari, if you want to take the lead.
Yes, sure. Thank you, David.
You're welcome.
So my name is Jari Šemeka, and I'm from VTT, which is one of the partners in this response project. And I was a task leader of this when we reported this master planning of these building solutions. So next slide, please. I will repeat a little bit the same things that the video had already. So, but the only thing that you really need to remember is that this kind of a city transformation, when we are making carbon reductions and everything, it's not just only the technical things. They are important, but there is always the citizen focus, so that their cities, the people are living there. So it's their living environment, so the engagement of people is really important. Also, the policy and regulations are the things that need to be considered. Should we change something? What should be done better? And that kind of things in city level. And then we're talking about smart city transformation. So smartness is usually something digital, and usually this kind of a city information platforms, digital solutions, communication around actually cross-boundary, because traditionally cities have been this kind of a silo organizations that each of them have their own things, and usually these don't, especially ICT systems, they don't discuss to each other, and that's one of the targets when you make better cities. And finally, maybe could say that the business models are important, so that beyond the project, for example, it's not just the demonstration the thing. There has to be a real good business for the companies for the coming years after the project. And then these sustainable districts and urban mobility things are they are these kind of technical things. We put there, install new technologies like was presented, and we are today focusing on these mainly, so don't forget the other ones, but today we are focusing on the building level and their technical solutions. And then you can show me the next slide, please. And this is how this mindset materializes in a response project. As mentioned, we have this transformation axis. Those three first ones, those TAs, you see lots of acronyms here, but these are the things how it's materialized at the project level. So first three, TA1, TA2, and TA3 are the technical ones. And then comes the digital solution, TA4, and then the citizen engagement and that kind of things in TA5. All of these contain the so-called integrated solutions. And we are focusing today that red rectangle there, and it's a TA1 positive energy building systems, which contains this kind of a building level renewable energy production. That's one topic. And then we concentrate on the items related to the, for example, deep renovation, what to do to lower the demand, because there are two things: increase the renewable production and then also minimize the demand. So these are two tools to handle the positive energy districts. And now we can continue in the deep dive into TA1. Next slide, please. So what the TA1, so this transformation axis, so this is a slang of response projects, so positive energy building systems. What are we doing there in practice? So target is to find the high energy efficiency in the building level, but also remember that good indoor climate is really important for the people who are living in the buildings. We are not building the buildings for the technology's sake. We are doing those for the building, but for the people. So that's done by, in Turku, we are making it's kind of a new building, which is highly energy efficient new building. And then these deep renovation activities, which will be next speakers will drill in the real details of these innovative elements, how it's been done there. But anyhow, mainly building level, how you do the renewable energy production. It's solar systems are this kind of a close to commercial or commercial solutions nowadays. So that's the things that we do here. So increasing the renewable energy production, the deep renovation activities, and these are, for example, better insulation, better windows, well, it's kind of a fancy exhaust air heat pumps, which is quite common in Finland. And these smart digital solutions are used for the people's better control, how to handle the indoor climate when people are present, and when they are absent, how to control the system so that it's most energy efficient, but securing the good indoor climate for the people. And the next speakers will tell that more about. Next slide, please. And then a short overview related to the target setting that we had a year ago. These are the examples, or not examples, but the planet solution target values of the energy demand and renewable energy production. So what is the change? The green is the baseline. So today or year ago when we started the project, and then what happens is that lighter color is there. Sorry, I can't know in English that color, but lighter color means what happens when we have completed all the innovations. And in summarize, this whole development is that we are doing this kind of a renovation activities. Dishon is doing more. If you look at the bars, how they are, Dishon is doing good work in energy efficiency side, lowering the demand. And then right-hand side, we consider also how to produce more local renewable energy to reach the target. And this so-called positive energy target is set technically so that the renewable energy share is there's an equation left upper corner, so that you divide the overall yearly production by the demand, and then you get the percentage. So they're around 120% both in cities, Turku and in Dishon. And if you make a distinction between the cities, the Dishon is relying mainly on photovoltaic solutions, and Turku is relying the heat pump solution. That's in short what's happening in both cities. Next slide, please. Oh yeah, now it's a question and answer section. So kindly write your questions related to these topics into the chat, and then we will come back to them after at the end of this meeting webinar. Thank you.
Thank you, Jari. So we can go to the next presenter, which is from Turku. Rauli, are you here?
Yes, hope you can hear me well.
Yeah, the floor is yours.
Thank you. Hello all. My name is Rauli Lautkankare, and I work at Turku University of Applied Sciences. So I will tell you about retrofitting solutions that are or will be implemented in Response project in Turku, and specifically in a block where the 4 buildings have reached the age of 50 years. My topic is retrofitting 50-year-old building block using state-of-the-art technology. Next slide, please. The renovation is carried out in Turku Student Village and in a block called 5th block. The block locates in the center of this drawing, and it was built in 1970. The block contains 4 buildings which are culture historically protected. There are altogether 91 this same type of buildings built in 70s, and these buildings have altogether 2,500 same kind of apartments. But in response, now the retrofitting concerns these 4 buildings. Next slide, please. On the left side, you can see the whole positive energy district, where the response projects is targeting all the actions, and P4 represents the 5th block buildings in our demonstration area. On the right side, a picture in situ. Buildings have 3 stories. Next slide, please. Here's the same block from bird eye view. 4 buildings, there are 18 or 36 apartments in a building. That means altogether 108 apartments in these 4 buildings. Historically valuable is the positioning and the shape of the building inside the 1 block. Facades are protected, and it means renovations need to preserve the original appearance. So it is not allowed to do changes to facade, and for that reason adding insulation into the walls is out of the question. It's not an option. Next slide, please. Retrofitting solutions are gathered here. There's 4 main solutions presenting state-of-the-art technologies and 1 conventional retrofitting solution module. The first innovative solution is nanocoating four-glazing windows provided by partner Ruhkala, a Finnish window company. Then the second one, novel high-performance ventilation system, where you will have detailed presentation after my part by Högfors GST. Then third solution is novel human thermal sensation control, from which you'll also have detailed presentation by partner Kiona. And fourth solution is self-sufficient IoT thermostats. And then 5th, conventional retrofitting, including water-saving taps, extra insulation to roof, urethane ceilings, mainly tightening and sealing the wall connections, and then PV panels on the roof. Next slide. The first solution to present in our demo buildings is nanocoating four-glazing windows. They aim to increase the energy efficiency of the existing buildings. Top-class energy-efficient windows have 65% better insulation value than the existing windows. The nanocoating forms a frost-free outer glazing and visual comfort for the resident. The state-of-the-art energy efficiency of the window provided by partner Ruhkala is based on the thermal break used in the exterior frame and the glass structure offered by modern glass technology. The thermal break and current selective glass coatings have improved the U value, which is the insulation of the window, by about 30% compared to previous 4-glass window generations. The expected installation time is 1 workday per apartment in these 5th block apartments. After response retrofit, the windows thermal insulation is even better than walls have it, because walls are still 50-year-old. Next slide. Here you can see the situation picked last week. Windows have been replaced in half of the apartments. After the window renovation, energy is saved 65% compared to old windows. Savings per 1 window might be small, but after replacing all 250 windows, the impact grows respectively. Considering the situation and impact, if all the 91 buildings in this area and built 70s would have these windows, or 1.2 million Finnish small houses and 300,000 other buildings have these high insulation windows, that would make a difference. And of course, buildings in other subarctic countries as well. I want to emphasize that even small improvements will carry us closer to better future, because they are, drops in an ocean that can be multiplied and scaled billions of times. Next slide, please. Here's some facts about the company Ruhkala that provides the state-of-the-art windows. Ruhkala is founded 65 years ago. It locates in the middle Finland, as you can see from the map. They have 26 employees and they are manufacturing 20,000 windows in a year. So it's a small size company that provides excellent windows with affordable price. Next slide, please. Then Student Village Foundation has made some conventional retrofitting by their own funding at the same time with other renovation measures. Here you can see work done during adding the insulation on roof. On the left side before the extra insulation and left side after insulation work. Next slide, please. And here a picture on the left side shows that there is a new roof material under construction, and on the right side that PV panels have already been installed. One building has 63 panels and their capacity is 25 kilowatt peaks. And now it's time for Högfors to present the ventilation implementation in these 5th block buildings. Thank you.
Thank you, Rauli. I'm trying to start the video, but it doesn't let me. So just a second. You can't start your video because host has stopped it. Okay, I can go without the video then. So yeah, welcome to you all from my side as well. Do you hear me? Is the line okay?
Yeah, we do.
Yes. Okay, thanks. Yeah. So you have my show over there. Do you have it? Should I share it myself?
No, it's displayed. You just have to ask to change slide.
Okay. Okay, you can change the slide. Okay, thanks. Yeah. So my name is Juha Virki and I'm representing company named Högfors GST. And today's topic is high performance ventilation system. And I have roughly 9 minutes time to get through. So I try to be as fast as it's needed. So first, you can change the slide. Little about us. So we are a factory located in Leppävirta, and we are importing district heating and cooling subcentrals and hybrid solutions to Sweden and Norway, and as well, of course, producing them to Finland as well. And we have about 150 employees and turnover is about 30 million. Next slide, please. So the situation before the renovations, as Rauli earlier said, that these are old houses and the typical ventilation is like this. So we have only exhaust air ventilation. And in this case, we have one of those in each of the buildings, rooftops. And when we have only exhaust air ventilations, the inlet air comes via vents, which are on the rooms. And what we have a problem is that when we have, for example, minus 20 degrees outside, the temperature coming into the building is the same level. And of course, this gives you a big energy losses and lower living quality. And what we are now doing is trying to change this. And let's go to the next slide. So what we are doing is that instead of taking the cold air directly from outside into the rooms, we are heating it up with inlet air units. So that means that when we have minus 20 outside, we can still blow plus for example, plus 18 inside to the building. And that, of course, gives the living quality much better. And in the same time, when we were before blowing out this plus 20 degrees air, now we can blow much, much colder air out. And that means when we take the heat out of the leaving air, which was plus 20, so that means a lot of energy savings, of course. And in the upper picture, you can see the, well, you know, we have quite cold temperatures here in Finland. This is something that we can have. And this is when the normal ventilation, like between the inlet air unit and the exhaust air unit, is working only without the heat pump. But when we have higher temperatures outside, for example, plus 10, then we can take the heat pump to the system to give like boost for the ventilation and for the recover operation. So this gives of course the smaller energy losses and better living quality. And this has the possibility as well to cool down the inlet air when we have hot outside temperatures. But in this case, we are not using it because of the ducting. If we should use the cooling, we should have the different ducting inside the building. So in this case, it's not possible. Next slide, please. So these are the modules that we have manufactured in our factory. So in the left side, there is district heating central. And that means that it takes the district heating and the heat pump heating power and uses it to heat up the building. So it can determine whether it uses district heating or backup energy. And of course, in this case, we are using as much as possible of the heat pump. And the second from the left is the small substation for the heat pump, and this one determines how much we are heating the domestic water and how much we are heating up the radiator network. And there in the middle there is the heat pump, and the next one to the right is the heat pump filling station, and the rightest one is the heating actually, which heats up the inlet air coming to the system. So these are the products that we have manufactured in our factory, and we have tested these before we are sending them to the site. And that gives the opportunity that the installations on site are much faster, and they are easily installed, much easier than normally when you like buy a piece by piece from a store, these kind of things. Next slide, please. And then we have the ventilation units. There was a picture in Rauli's presentation where you already saw one of those exhaust air units. So this exhaust air unit, what it does is that it cools down air that's going out from the building. So normally when we have this plus 20 degrees outside air, it cools down to -5 when we have cold outside temperatures, and when we have plus 10 outside, it cools down. It's even lower to that outside temperature. So for example, +4. And on the right side, we have inlet air unit, and this is the one that heats up the air coming inside to the building. Next slide, please. And of course, when we have a lot of different modules, heat pumps, heating circuits, ventilations, etc., we have to have a control system that can control everything. So this is something that we are doing as well in our factory. And when I talked earlier about the factory testing, this is a big part of it. Because before we send the products to the site, we test everything and this fixer system as well. So actually the automation is working already before it's installed. With this control system, we can get all the consumption reports, for example, how much electricity the system is taking, how much heating power it's producing, and everything can be controlled via internet. So, for example, if you have a cell phone or computer or whatever, you can control the whole system by using those. Next slide, please. Well, this is the flow chart. It's maybe a little too difficult to explain for you, but just the closure. This system is prefabricated system in our factory, and it consists of different modules that are connected on the site, and that's it. You don't need to actually think every module, every product, every vent differently, but everything is already done in the factory. And next slide, please. Oh, that was all. Thanks.
Okay,
So
then I'll
it's
go next.
I transfer it to you. Thanks. Bye.
Thank you. My name is Mitra Hajigoli, and I'm a data scientist at Kiona. I'm also the project manager for Kiona in the Response project. And I'll present to you how Kiona is reducing emission from buildings through the monitoring, control, and optimization of energy usage. Next slide, please. Kiona is a leading SaaS and PropTech company in Europe. We have the common ambition to build Europe's leading flexible, open, and independent PropTech platform. We offer software and services for technical property management, energy optimization with AI, refrigeration management, and environmental and energy monitoring. Next slide, please. Our cloud platform, Edge, that is used in Response is a combination of two things: a cloud-based tool for digital control of property owners' portfolio, and a self-learning optimization of their heat usage. Next, please. With the Edge platform, we have an IoT platform built to deliver value fast. It should be easy and quick to install, so that we can spend as little time as possible on getting started and instead delivering data and results. Kiona Edge is a hardware independent and can be integrated with existing hardware infrastructure, enabling access to data without sunk cost. Next, please. Now let me walk you through the solutions Kiona is part of in Response. Next. For the Response project to succeed and to reach climate neutrality by 2050 in Europe and by 2029 in Turku, we need partners, decision makers, and citizens to collaborate. We need citizens to understand how much their behavior costs in money, energy, and CO2 emission. We at Kiona believe that a knowledge platform reachable from your phone is a good tool to increase citizen awareness. And here are some examples of what it can contain. Next, please. To create a connected city ecosystem in the Response project, a city information platform is needed for the decision makers. In this solution, Kiona will offer a dashboard to understand how efficient the buildings is in distributing and using the incoming heat over time. The dashboard will present benchmarking on building, but also on area level to understand how well your building performs compared to other similar buildings. It will also present the health of the heating central, which is based on district heating temperatures and energy consumption. And to find new, surprising, unexpected events or behavior on district heating temperatures, delta T, Kiona offers a rule-based anomaly detection tool to detect these deviating values. from what is expected or is normal. Next. The Kiona platform and IoT products are installed in the whole positive energy district area, marked in blue. In the positive energy block B4 to the right, Kiona solution is used together with the human thermal sensation control in 2 of the buildings, developed and led by VTT. Next, please. The human thermal sensation control is about keeping tenants satisfied of the indoor climate. The algorithm decides the indoor climate is based on body type and is used under and uses the indoor climate data provided by Kiona. Next, please. However, the solution is also about optimizing the energy consumption, improve our edge AI to the next generation, and to cut power peaks based on the energy tariff model set by Turku Energia. Kiona self-learning optimization calculates the building's heat need based on the predicted weather forecast, but also on the maximum indoor climate set per thermostat. Kiona will have the final control of the indoor climate to be able to cut any power peaks and redistribute the heat over time. Next. And here you can see a summary of what we will develop in the response project. And if you have any questions, please write in the chat. Thank you.
Thank you, sorry. Thank you, Mitra. That's it, I believe, for Turku's presentation. Let's jump to France and Dijon.
Yes, David, I'm here. Hello, everyone. Can I go? Is it okay?
Yeah, we hear you.
That's okay.
Yeah, we hear
nice,
you. Yep.
nice. Okay, so hello, everyone. I'm Adrien Rouchette. I'm the project manager of Response Project for Dijon Métropole Municipality. And now we are going to talk about what Dijon is about in the framework of Response Project. So next, please. So here is Dijon. I will give some presentation about Dijon, the project and the approach of our city. And then we will have a specific focus on the technical smart building solutions that we are developing in Dijon, because there are 3 of them. Actually, we have 3 partners working on this. So Lada Pliatsok for OGA will give a presentation. Then we will have Devani Pereira for Bouygues Construction. And finally, Quentin Antoine from the city of Dijon for the smart solutions in the public school. But first, let's go with the presentation of Dijon. So next, please. So Dijon, as you can see, is a rather ancient city in France, and it's also the capital of Burgundy. Next. Although it is rather old, it has been reinventing itself since the early 20s, yes, 2000s. So, for example, we have now the tramway. Next, we have the pedestrian zones. Next slide, please. Please. Yes, thank you. So here you can see the new pedestrian zone, which starts at this crossroads and all through the district that we can see in front of us on the right side. And we also installed a heating network during the very same works during which we had the trenches for the tramway. Next, please. In 2008, Dijon signed the Covenant of Mayors. And in 2019, Dijon voted for carbon neutrality starting 2050. So these here are the representation of the goals for Dijon. And in this scope, the Response Project is one of the testing way for the transition project for Dijon, and the reference pilot project in Dijon for energy transition. And for this one, we'll go to the next one. For this one, we chose the Fontaine-Douche district. Next, please. This district, which is southwest of Dijon, was built in the 70s, end of the 60s, beginning of the 70s, and it's called the Fontaine-Douche district. And it is home to a bit less than 10% of Dijon city population, so it's not a small one. And it has a particularity to be to home a relatively high level of poverty in Dijon, relatively to the rest of the city. As a consequence, the Response project in Dijon is the opportunity to test the energy transition in district for all citizens, which is a rare opportunity. Next, please. The district is located next to the lake Kyr. So Kyr is the name of the lake, Kyr, K-R-I-R, sorry, which is a favorable and a pleasant environment for the people. Next, please. The city also have many facilities in the neighborhood. For example, here the commercial center. In the next slide, we will have the sports center, the theater, the swimming pool, so sports facilities. And all the buildings are heated with the district heating network. Next, please. Even before the Response project, the Dijon Fontaine-Douche district was already under transformation. So we have this blue zone, which is already experiencing transformation since the middle of the 2010. And now we have the Response project, which is developing in the two yellow zones, the two PEBs for positive energy blocks. And those concern 3 schools, 5 residential buildings, 2 sports facilities, and the road spaces, as well as the district heating network. Next, please. The goal of the Response project in Dijon is to go energy positive. So we have the reference on the left with the energy consumption and the energy production in the district. And on the right, we have the goal we'd like to get in 23-24. So the first lever in order to reduce the need for energy imports is to reduce the energy consumption directly at the root. So that's the orange bar, in fact. But at the same time, it is also possible to produce energy which will be directly consumed in the district. And it's about the green part here with the PV panels. I will give some information about this in a minute. So let's go see the district. Yes, thank you. So please note that you can already visit the Positive Energy District in Dijon due to the digital model that you can get online with the link or the QR code. Next, please. Let's start with the residential buildings, which are home to more than 600 people, and those buildings are property of the social housing building owners, which is Grand Dijon Habitat and Orvitis. Those are partners of the project. Next, please. For example, Orvitis have renovated their buildings. We can see the difference here. So we expect, due to this improvement of the building, a decrease in 40% in the heat consumption of those buildings. In addition, we will have solar panels, which are not set yet, so I cannot show them at the moment. But we will have solar panels on top of those buildings. And we expect to have those in the end of year 23 or beginning of year 24. And this will reduce the need for importing electricity for the tenants. Next, please. As I said, we have 3 schools and a sports center. I will just give a word about 2 of the schools. Next, please. So we will start with Buffon School, on which we have everything we can as a matter of solutions on the Response project on this school, on the bottom of the left picture, with this new superstructure, a wooden superstructure, which carries many PV panels, so many PV panels that it can produce more than it consumes. And it is common during the day to have more consumption than the needs of the school. And due to the self-consumption law that has been set in France, we can share this electricity, which is produced on the building, in other buildings which are property of the city, such as, for example, the other schools or the swimming pool. And this facility on the school is already running since September 22. So it's one of the biggest achievements of this end of the year. Next, please. So the school, this is another example of the Colette School, which is currently experiencing the thermal retrofit, which will reduce the energy consumption in both heat and electricity. And this school can get some of the electricity from the 2 other schools, which will be equipped with those PV panels. So as a consequence, the schools and the residential buildings of the program are being equipped with those technologies that I've been talking about, but I've been missing something, the various smart building technologies that will further reduce the energy needs of those buildings. So, for example, the schools will get innovative systems for managing both the heat and the air quality. Bouygues Construction Company will provide predictive thermostats to the Orvitis buildings, and OGA company will provide smart energy management systems to Grand Dijon Habitat dwellings. So we will hear from them, because they are actually the specialists. I'm not, I'm just the project manager. As a consequence, I propose to give the floor to Lada Pliatsok for 5 minutes, about the OGA solutions that will be deployed in the Grand Dijon Habitat buildings. Lada, please.
Thank you, Adrien. Hello to the monde. So I am Lada Pliatsok. I'm the coordinator of the response project at OGA. And I am here today to present to you what we are basically doing and how we will be implementing smart energy management systems in the project. So just to briefly introduce ourselves, we are a French company. We are specialized in energy efficiency. So we are making smart home and smart building solutions since 2014. We do both hardware and software services. So basically our aim is to bring more comfort and to bring more savings to people who need it the most. And that's why we've been working a lot with social housing associations along the way. And in this project, we are working again with our partner Grand Dijon Habitat, who is a social housing association as well, to implement such solutions on their building. Next slide, please. And next slide once again. Thank you. So the problems we had in the building of the housing associations are actually quite common. The first problem is overconsumption. So as the flats are not heated correctly, there is no heating regulation. We can see that overconsumption is really common in these buildings. And for example, in the winter, you can even see people opening the windows because they're too hot. So our role here is basically to provide with the right quantity of energy at the right moment so that we can reduce energy consumption and bring more comfort with to our tenants. And in this case, we will be equipping 100 dwellings with Grand Dijon Habitat. So the second problem was a little bit more global. So it's heating network overload. That is to say that during the day in every building, you will have energy peaks when the network will be too much loaded and it will be difficult to provide energy to all the people who need it right now. So our role will be to smooth the energy consumption peaks, basically to avoid this overload. And now I will explain you how to do that exactly. Next slide, please. So in the flats, to avoid overconsumption, we will be installed in our smart home solution EcoTouch. So basically, it's an energy manager. It's a small module that will be installed in the electrical panel of every flat in the building that will measure and analyze energy consumption and will learn the habits of the people living inside. So according to these habits, it will automatically regulate energy consumption. To help them use the system better, they will have a wall switch that will be able to get the temperature that we like. So they will set the temperature on this switch, and the system will do the rest. Also, to help us learn better their habits, and also to get more energy savings, we will have a wall switch near the entrance, and it's basically a presence and absence button. So when the person leaves, they will push the absence button, and then the lightings will be off and the heating will be reduced. And when they come back, presence button, everything is back to normal. So the system is quite simple and easily used by any tenant of any age. And the thing to remember is basically that the heating is operated automatically without people doing anything, depending on their habits and also on the weather. So there is no programming to the system. The installation is very fast. It's less than 1 hour. Next slide, please. Another interesting feature about the solution is that we will have automated thermos valves that will be installed near on each radiator near the windows, and basically we will be detecting a window opening if in the winter, for example, someone opens a window. So we'll be able to tell that we need to cut the radiator near that window. It will allow us to avoid overheating. We also sponsored the certification of this valve that will allow to housing associations to get significantly reduced installation costs. So it is also a thing to remember. So now we will be shifting to the smart building part. Next slide, please. The second problem will be tackled in this way. So to avoid the overload of the district heating system, we will be able to say when exactly there will be a peak of consumption, for example, in 24 hours at 6 in the evening. So according to that forecast, we will smooth energy consumption, and we will basically say to the systems in the building to launch the heating just a little bit earlier or later than the peak, so we can basically smooth the peak and avoid the launch of another power station, for example. So I think it's all for me as for now. So I'll leave the word to the next participant. Thank you. If you have any questions, please write in the chat.
Thank you, Lada. Thank you very much. I propose to give the floor to Devani Pereira for Bouygues Construction. Are you with us, Devani?
Yeah, I'm right here.
Yes.
Hello.
Go on.
So continuing with a very similar solution, we are working with Smalt, which is another affiliate of Bouygues Construction, who specialize in connected objects in buildings, tertiary and housing projects. The solution that we are trying to tackle is trying to give controllability and visibility on the energy bills, and looking more at it at an occupant aspect. Because today we have a couple of challenges, and one is the fact that we do not have a visibility on our choices that we make within our apartments, on our final energy bills. And also the fact that we have very little controllability. So these are the two things, or the three things, that we try to tackle with our solution. If we go to the next slide. Right. Okay. So by having a better visibility on our energy bills, what we would like to do is to give controllability and reduce the energy poverty that is getting more and more common today. And of course, doing all this with a user-friendly interface, so that it's a solution that can work for people. So if you get into the details here, it's a little bit different compared to the solutions that we provide here. There is an algorithm that goes into predicting the user behavior. So what happens is the network gateway basically collects all the data, and it is able to then, using an artificial intelligence and an algorithm, predict the user profiles. And this user profile then provides us with their impact on the energy. And if, for example, today their user profile says, okay, with 25 degrees, you have this kind of energy consumption. Let's say tomorrow they say we want 27 in our apartment. They are capable of increasing their temperature via a user-friendly application and say, okay, I'm going to add my temperature to 27 degrees, but the difference here is going to be, we would be then showing them their impact on their choice, on their energy bill. Of course, this is not going to be an easy task because the energy bills, the energy costs are fluctuating, but we would like to give them an average impact of their choice on their energy bill, so that then they say, you know what, I want 27, I have 25, but if it's going to be that much higher, I'm going to maybe put an extra layer of clothing on me. I don't know. So these are the kind of things that we try to our objective is to help the people also understand the choice that they make and the impact that they have in their energy usage and their bills. If you go to the next slide, we'll see a little bit about the type of screens we see. And these are the typical screens that we would see in a lot of the connected thermostats that we find today. So it would be a very similar user-friendly format where we change the temperature, where we can see the impact on the energy bill, and it can set all the set points, and those are very, it is becoming more and more standard in the market today. So, if you have any questions, please go ahead and ask any questions in the question and answer session. And that's about it, about our solution that we are presenting for response.
Thank you, Devani. So not exactly the same solutions, but some ideas in common. So yeah. Just before we had this slide about those 4 sites, 3 of them are the schools, and the last one is the sports center, on which Quentin is working for the city for the smart building solutions, the third solutions. Quentin from the city, can you hear me? A presentation. I can hear you.
Is it okay? Okay, yeah. Perfect. Thank you, Adrien. So I'm Quentin Antoine. I'm working within the energy department of the city of Dijon, and especially in the Response project, I'm in charge of deploying various technical solutions for the Dijon city assets, and especially some smart buildings technology, which we are discussing now. So first of all, the main objective of this solution, as Adrien explained before, is to create positive energy district. So it means above all reducing the energy consumption of the building that make it up. But also in the school, the subject of indoor air quality is really important because of public health issue. We need to take care of the health of the people. So, and finally, the subject of comfort in the building is extremely important. We need to take care of the comfort of the people using building to make them actors of the energy transition. So it's an essential prerequisite of the acceptance of the energy performance, I think so. So we analyze these three problems, and with it that we are faced with three equations, which by their nature are opposed to each other. So it's a big paradox to decrease energy consumption, increase comfort, and increase air quality. Next slide, please. So you can see on this slide that reducing energy consumption implies lowering or precisely controlling building temperature. This can quickly lead to a reduction in the comfort level of the building. It also means reducing all electricity consumption. To improve air quality, building must be mechanically ventilated, which means that fans consume electricity and energy is lost through the air. Finally, in order to guarantee optimal air quality, the sizing of the ventilation can sometimes lead to uncomfortable feelings of air movement. So it's really difficult to make the three problems working good together. Next slide, please. So the problem we're trying to solve is the following: how to improve the 3 points explained above while ensuring a balance of treatment between the 3 points. We're deploying a solution with 2 partners in the project, 2 industrial partners, NanoSense and Alizolo. This solution is based on different points. The first point is the installation of room by room heating control equipment. We need to control perfectly heating in each piece of the building. The second point is the installation of ventilation equipment, which also be controlled by room. After that, we need to monitor of indoor condition by multi-factor sensors. We need to sense temperature, air quality, CO2, COV. And the next step is to put an intelligent control of all this equipment. We need to make it work good together. So we need to analyze all the factors and put it working well when it is the best time to work. Next slide, please. We put intelligent sensor because the sensor in the school will have the capacity to measure, but also to control the equipment. It's really important we put intelligence on the edge and on the cloud, not only on the cloud. On the 3 schools we are trying to develop this solution, we develop different scale of installation. In the Buffen school, we will be fully equipped. So each room will have temperature sensor detecting window opening, and the control will be adapted to the condition in each room. In the college school, we will have a little less equipment, no window opening sensor, 1 sensor for 2 rooms. And finally, in the Anjou school, we will have few sensors, only 2 per floor, but each room will be controlled. The main objective is to try to measure the impact of the level of instrumentation of the gain for each of the 3 objectives, and determine at what level of investment it is relevant to place oneself. Next slide, please. So to finish, just a few words about the general planning of the implementation. We are now finishing the renovation of the before schools, so it will be on work at the end of the year. The college school is now deploying, so we will start to make it work on March, I think. And the Anjou school, we will not be renovated. It was done some years ago, so we just installed the necessary equipment during the next summer holiday of 2023. So thank you very much, and I lead the floor.
Thank you very much, Quentin. So this was the propositions that we have on TA1 for Dijon, and we had these good presentations from the specialists. So I'm glad we had them today. Thank you, all three of you, Lada, Devani, and Quentin. I think if you have the questions on this, you should write them down in the chat. And if you want to visit the district, you have the QR code here on the slide. Thank you.
It was perfect, Adrien. Thank you for this presentation. Thank you to the Dijon team. We are going now to jump to the fellow cities. So we have together with us today City of Zaragoza and City of Gabrovo, and they are going to explain what they want to replicate regarding the solution in their own cities. So Breogán, I think you are the first one.
Yeah. That's it. Thank you, David, so much. And thank you all participants to be here today. I hope you are enjoying as much as I'm doing with the innovations from Turku and Dijon. It has been very interesting. So my name is Breogán Sanchez, and I work for the Zaragoza City of Knowledge Foundation, together with the Smart City Department for the City Council in our flagship building called Etopia. Just to put a little bit in context for those who are not familiarized with the city, Zaragoza is located right between Madrid, Barcelona, Bilbao, and Valencia, and counts with nearly 7 million inhabitants. It's a very compact and medium-high density city with 7 million inhabitants, only covered in roughly 6 kilometers by 5 kilometers wide. And talking in general terms, Zaragoza is the logistic hubs for the main cities I explained before. And we have also signed the Covenant of Majors, and CCAP is being in process right now, which will include some of the measures that we are going to talk today. Lastly, just to mention, by the IMD Smart City Index, the city is ranked as the number 15, so 1-5, worldwide in the last ranking made on 2021. Okay, so what we see here is a brief image of the center of the city, and we are working in two PEDs. So the one that we see in the right side, PED 1, mostly based on retrofitting and refurbishment of renewable energy sources in all neighborhoods, and the PED 2 is right here where I'm talking from, is an equipped park right in between one of the two most populous neighborhoods in the city, and right across the main central train station. So can we just jump the slide, please? So just a quick overview about it. The neighborhood that I was talking about in the PED 1 has been built in the 60s and is a workers' neighborhood with currently lack of accessibility and a degree of social marginalizations. For the second PED, which is in the left side of the presentations, This is an equipped area, which is currently used as transit among the two neighborhoods, as I just mentioned, and which will have an opportunity within Response to be included as a digital layer and involve communities. And imagine how this space with that digital layer can be equipped to test new devices, new system like charging and all the innovations that can come to the city, which can have for hand a place to be interconnected. I'm going to be focused by the subject of the conversation today, of the webinar today, to the PED1. Well, as we can see here in the image, this is a building from the 60s, which has been newly refurbished. So isolation has been applied. Also, an elevator has been installed, is what we can see now from the image. As those buildings, apart from getting old themselves, its inhabitants are getting old. Therefore, it presents a very high level of elderly people, which actually became one of the main challenges when trying to make investment, since we encounter most of the inhabitants to be against any further investment, as they did not longer see the benefit of it. So if we can just jump, and I will give you some details about this PED. So the neighborhood is more or less what we see in the screen. We are counting on roughly 50 residential buildings. Can be in towers of above 6 level, or the most common type, which is blocks of 4 or 5 level maximum, which intend to be convert into a positive energy district, both by implementing renewable energy sources such as photovoltaic, or mainly photovoltaic, but also by conventional retrofitting, which includes replacement of radiators, changing of lights, and also insulation, among others. So we are in this moment creating a neighborhood office to invite all the residents and also facility users. I forgot to mention that we are not only speaking about dwellings, but also about equipments such as schools, such as there is even a church or commercial center here, and are invited to check how initiatives like Response and the overall strategy for the neighborhood can help them saving energy and contributing to a better city. Also, the energy provided, I mean the energy pure to the system will be concentrated into local energy communities. So the idea is also to generate a social mechanism to take advantage of the energy that has overpassed the consumption, let's say. Together with the Response project, we're taking and intend also to take good initiatives and ideas from Dijon and Turku as well, in what regards the installation of conversion of photovoltaics and also the retrofitting activities that I was mentioning before. Well, we are now also analyzing the potential areas in which the photovoltaic can be placed and identify which is the level based on the baseline that can be saved after the next years. And I think my time is gone, so I will not take more time to Gavrovo's presentation. Thank you so much.
Moikka. Onko sun hetki?
Okay, can you hear me? Yes, anybody say hear me?
Yes, we hear you well. Please go on.
Okay, so I will be trying to be a bit of quick representing Gabrovo. For those who don't know, Gabrovo is just in the very middle of Bulgaria, and it's one of the most beautiful cities in our country. So according to the project response, what we try to do is really increase the level of energy efficiency in the building, increase the renewable energy source generation on site. And in the past few months, some activities have happened. For example, I will start with the three most important buildings in the project. The first one is the administrative building of the municipality. Right now, what we have decided which are going to be all the energy saving measures. We decided what the innovative elements will be, and the next step is to make the technical design of the building. So what we decided to do is just to replace the current heating system, construct a PV generator with around 80 kilowatt peak power. So we also have to do total replacement of the heating system, and of course implementation of automated system for control of the heating, and partial isolation of the roofs and the walls. Because maybe you can put the next slide. You can see this is the building. We don't want to change the architecture of the building, and it's very important. And you see one of our biggest disadvantage as this building is the tower we have. Sadly, it's pointing directly south, so it reduces the PV generation we can do, but still we will manage to get a lot of power from the sun. And what the aim of the municipality is to achieve the highest possible class of energy efficiency according to our legislation. And it's really also not so hard doable. So maybe the next slide. The next building is the sports hall. This is a bit more challenging building because the sports hall is a very big building, and right now the first thing we need to do is to make a constructive survey, because we have special construction on the roof, and we have to decide whether we can get PV panels or no. So additional, not only for the PV panels, we are going to replace the heat supply system, total refurbishments, and everything. So maybe you can put the next slide. This is the sports hall. So you can see also here we can use big roof for photovoltaics, but the exact amount will be known after the construction survey. The next slide. And the third very important building is one medical center, which is slightly ahead of all of the other buildings, because we already have the technical designs for everything, and we hope that around September next year we can start implementing all of the innovative elements. The next slide. This is how it looks. Again, it's with some special architecture, but also, like every other building, right now we are trying to achieve the highest possible class for energy efficiency in Bulgaria. So this is very important. And the next slide. These are the specific problems we have in our municipality. For example, the administrative building and the medical center operate only from Monday to Friday, and the generated energy during the weekend cannot be utilized. And this is a legislative problem, so hopefully we can try to figure out a specific solution directly with the energy supplier. Also, the coordination procedures with the energy operators take a long time, and usually one implementation of PV system, for example, takes around 6 months, which is something that's not really normal in the other parts of Europe. And this is how Gabor is doing right now with the response project. And that's also from me.
Thank you, Vladimir, for your presentation. It was very effective. We can now jump to the Q&A session. So feel free to ask any question if you have question. Douglas, at this time, can people
Yes,
speak,
yeah,
or
people
they have
can.
to write?
I think it's easier for people to write since we have 40. Yeah, we have over 50 people here.
Okay,
but there's a
no
question
worries.
which was partially partially requested, which are partly answered, I think, from Maria from Maria to Jerry. But I also see a hand up from someone. Can I ask
This
them?
is Slava, I think.
Yes. Can you unmute Carolina, please? No? Okay. The question was concerning about digital solutions to the Turco ecosystem. Can you any more about digital solutions related to digital tools to handle heating flexibility? So the question was about how flexibility was taken into account. And Jerry, I wonder if you have any further comments on that.
No, I just mentioned that there will be presenters like Olga and Kiona, and also Orvitis were handling this issue related to digital solutions at the building level. And then I mentioned that we have also this energy storage batteries and that kind of things, but that's a question of another webinar.
Yeah, if I can complete, thank you for your answer, Yari. But yeah, we have a solution at the building level, and it's the aim of this presentation today. But we also, in order to get a positive energy district, have solution at the district level with second life batteries, phase changing material tanks that will bring flexibility to the districts. But it's not the purpose of this precise webinar.
There was also a request from Kaleva. You had your hand up. I wondered if you wanted to make a comment as well. No, I believe you put your hand back down again. Okay, so thank you. In the meantime, actually, we don't have any further questions, but we have 2 more minutes to the 2 more minutes to the end. So in the absence of any further questions, David, maybe a very quick wrap up.
Yeah, first, thank you for all the panelists to present their solution, and thank you for all the to all the attendees to be here today. I hope you learn a lot about the solution we are implementing within the Response project. What we learn, or what we try to explain you today, is about one precise transformation axis of the project. So just to remind you, we have 5 transformation axes. It's collecting or gathering those 5 transformation axes that we will succeed into turning our district into positive energy district. So we are here talking about just one axis. And during this presentation, thank you again to Turku. We had the presentation of what are the solutions within this transformation axis for Turku. So they talk about 4 main solutions. That was nano coating for glassing windows. So they are changing the windows from old building with 4 glasses windows, so more modern windows. They are working on the ventilation system. They are working on low volume and thermal control devices. They are installing self-sufficient thermostat, and they are also doing more conventional solution, which is changing the insulation, for example. During their presentation, I don't think they mentioned one point that is important from this for this transformation axis point of view, is that for sure we are working on how to reduce the consumption of the buildings, which is about insulation, which is about ventilation, which is about how we use the heat more efficiently, but it's also about producing energy within this transformation axis. So I think I remember we are producing energy in Turku thanks to PV panel, so bifacial solar PV panel. We also got a presentation from Dijon side with some kind of similar solution, because we are in both situations try to improve the buildings. So in Dijon, they talked about the PV panel, which are included in a self-consumption solution. We talked about thermal retrofitting. We talked about smart building solution with predictive thermostat, with smart energy management system. We had a presentation from Moga, from Bouygues, and from the city itself. And then we open this conversation to 2 of our 6 fellow cities. And Zaragoza explained what they want to achieve in one of their PEDs. And the same for Gabrovo with 3 buildings and 3 examples of what they are going to do when we talk about transforming their building stocks. So I hope you got a lot of hints of answer. Feel free to reach out to us if you have any further answer. And in the meantime, I can wish you some pleasant end of the year's holidays. I'll see you for the next webinar. I don't know exactly when it will be. It will be sometime during the first trimester of 2023. Thank you very much for being here, and have a nice day.